Good afternoon. Great talk, Karan. It's very interesting to be here. Thank you for inviting me. And today I will be talking about the work we have been doing and the vision we have towards a haptic-based multimedia environment, which is a digital twin. So first of all, welcome all here. And I am from the University of Ottawa, which was established in 1948 as a Viscount College. We are the second biggest in Ontario and the fifth in Canada, top 200 in the ranking. We have University of Ottawa is in the city of Ottawa, which is the capital of Canada, because most of you think Toronto is it. And it's a multicultural city where we live from government and from embassies and to universities. University of Ottawa is the heart of the city, and it has the shape of a heart. And within the University of Ottawa, there is a Faculty of Engineering, which has three departments and a school. The school is a marriage of computer science and engineering. This is why it's called the School of Electrical Engineering and Computer Science. In this school is a multimedia communication research lab that I have been leading since 2002, and we are working on different characteristics related to multimedia in general, where haptic is part of the media that we consider. Now, what is digital twin? Digital twin is a digital replica of any living or a non-living physical entity. And the goal of the digital twin is to bridge the real and the virtual world so that any interaction in the virtual world is reflected in the real world and vice versa. According to Gartner, digital twin is the fourth on the top 10 technology trend for 2019, and more than 50% of IT companies' teams have digital twin in their annual report. So consequently, according to Market Research Institute, digital twin market will reach around 15 billion by 2023. So why digital twin is so important? Because if we look at facts, we are witnessing things that are being interconnected, IoT. We are witnessing data, big data, and artificial intelligence. We are looking at multimodal interactions, cybersecurity, and biometrics. And we have the telecommunication world, and particularly today we are talking about 5G and tactile internet. But all of those are islands, and they don't talk well together. The digital twin is a convergence, or my vision of the digital twin is to be the convergence of those multimedia technologies, where the islands become interconnected, and consequently we don't work in one area and we neglect the other. Otherwise, it will happen exactly what we heard in the previous talk about the designer. So what is our journey with digital twin? It started back as 2002 and didn't end, but in 2011 it was we came out with the haptic technology book, where we looked at it, where we had the multimedia, we have the haptic perception group, we have the robotic or haptic robotic group, hardware, and we had the computer graphic or haptic rendering group, and they were not, at least there was a lack of interconnection between them, and we thought that haptic technology, the multimedia, could be the roundabout where those three fields can merge together. Our first approach toward merging those issues is very interesting, because Haptimedia or Wikimedia that Carl was presenting is a very interesting work. We have the HAML, Haptic Application Meta Language, where we try to describe and identify the haptic devices as well as haptic rendering, haptic algorithms, haptic communication, quality of experience of haptic, and haptic data description. And the goal for it was to facilitate the development of haptic applications so that we develop one application and we use it with different haptic devices, such as the moving a cup in the rehabilitation process. And the same haptic application is used with the phantom single point of contact, or with the cyber grasp with 22 point of contact. Now, haptic authoring is a very difficult task, and everyone needed to develop its own haptic application. Consequently, we looked at open software in order to be able to develop haptic authoring tool, and we applied haptic HAML as part of the multimedia authoring tool, where we could directly in a graphic user interface add the stiffness, damping, static, and dynamic friction. From a step further was with the introduction of HTML5 and JavaScript, where we moved the whole haptic description language into the browser as a plug-in of Chrome browser in 2013. Now, one of the applications that is very interesting is basically when how to trigger different senses or different emotion of messages in your pocket when you have a cell phone, so that you know from whom the message is coming and what content is in it. So we did what we call natural language processing, and depending on the emotion in the message, the vibration intensity and the vibration strength will be different. That was the early work on haptic authoring. Now, later on we saw, what if I need to be here, but at the same time, I want to be somewhere else? So I need to be teaching, but Barcelona is playing, as you know, on Wednesdays. They are playing today's Copa de España, and I want to do both of them. So how can you help me in achieving, how can haptic help me in achieving this goal? In order to achieve this goal, I need a digital twin of myself with a high precision. One thing is to look at what is the precision I can go in, and with 2.5D perception cameras, such as the Kinect, we were able to get up to 2 millimeter precision in up to 3 meter vertically and 3 meter horizontally. Now, when we try to capture a subject or an object, what is also how deep can we interact with this object? How good can we interact with this object? So we performed a kind of what we call 3D scanning in order to see whether different haptic property can be, graphic property can be measured and haptic property can be applied to it. So the first, or one of the projects I performed in this regard was a Kinect on top, mounted on a robot with, in order to get the 3D human head scanning within 1 minute. Using Kinect Fusion, we were able to get this model in within one minute, and then send it either to 3D printer or send it to a 3D gaming engine, for instance. And then we looked at the haptic stiffness rendering characteristic by looking at the skull models and the point, and doing what we call iterative point modeling and applying haptic characteristics on the different region of the head or of the body, and then being able to interact with them and being able to touch the subject. Now, this led to a problem that if I want to send my avatar to the student needed a haptic device. So consequently, we start thinking about different modality of interaction with the 3D avatar or hologram. One of them is what we call magnetic rendering. And in particular magnetic rendering, if we make it a unidirectional magnetic rendering, we can look at the intensity of the magnet, and at the same time we are healing the subject. From a medical perspective, unidirectional magnetic is very healthy. It's very healthy for the tissues and for the bones. Now, we performed a couple of simulation studies, and based on the simulation studies, we find that if we do a 3x3 or 5x5 matrix of of what we call magnetic field array, we at 1 centimeter we can feel just a groove or very rough structure of a face. However, so now here we will see it. So at 1 millimeter, 1 centimeter, that's the face, the force generated for the face, so it's very difficult to distinguish that it's a face. At 2 centimeter, now we start being able to distinguish nose and mouth maybe, but at 3 centimeter, we have a very good touching capabilities of the body. We went from the simulation, and that's why I really liked I really liked the discussion today and the talk previously. We do simulation, we find something, and then when it comes to the reality, it doesn't work. We developed this electromagnetic field. It's a very heavy device, a couple of 7-8 kilograms device, which require a very tough electric generator. It costs about $15,000 US in order to generate a wave. So it's practically simulation-based is doable. Technically, practically, it's not doable. Another field of studies that is very interesting in multimedia computing is what we call quality of experience. So we from a communication perspective and networking, we talk about quality of service, which considers jitter, delay, loss, and security, but very little is done about user experience. So we performed an analysis, and we came up with a classification of user experience into 4 main categories: perception, measure, rendering quality, physiological, and psychological measures, and each of those categories has a subcategories. Then we built a mathematical model in order to find the relationship between quality of service parameter and quality of experience parameter. Now we know that we assume that haptic, or the way we touch, is unique by a subject, and we performed a couple of studies in order to understand whether haptic can be used as a biometric, and in particular as a behavioral biometrics, by applying different types of classifiers and different type of application. We figured out that there are different type of application depending on the memory. So things that we do consciously differ from things we do unconsciously. Things we do consciously, for instance, is when we solve a maze. Things we do unconsciously is when we dial numbers. So, and consequently, we find that the false acceptance rate differs depending on this type of application. Now, to have the complete haptic multimedia immersive environment, we developed what we call a haptic book. So we looked at PDF, open source PDF, and we looked at the text. We applied a kind of NLPs, and we were able to extract the emotion, but also the movement, the actions in the text. And then through eye contact, we know on which paragraph we are, and depending on the paragraph, which is annotated, then haptic feedback is provided. And this is probably the last comment that the gentleman in the back made in the first session, is what I believe where haptic killer application could be, that we move the haptic from the fingers to the whole environment, where the smart environment becomes a haptic environment, and then we are reading or watching a movie, and the complete environment is moving with us. And we also we developed a couple of applications related to haptic, augmented reality, and artificial intelligence in order to support post-stroke patients. And if you can see in this example, basically we are using augmented reality with serious games, and the subjects with the stroke or stroke patients are performing testing and trying to improve on their behavior. Now, this led us, in fact, around 2012, 2013, 2014, we had a shock in haptics, in the fact that because we are not haptic hardware developer, we are just consumer of it and building a multimedia application, we didn't know where to go next. Until recently, in 2014-15, we started looking at it, as I said, from a smart environment, and we decided to look at a reconfigurable transducer network, so IoT plug-and-play environment where with haptic feedback, regardless of the feedbacks that we provide, whether it's vibrotactile actuator or heat actuators, it didn't really matter as long as they are talking the same language, and the same language is based on sensor ML. And then the medical field and the Medical Device Innovation Institute start evolving, and we needed to train athletes on a couple of characteristics, such as running, sprinting, and knowing how they are walking and sprinting. So we developed what we call insole with sensors and actuators inside them. So when they are sprinting or they are walking or running in the wrong way according to the coach, a haptic feedback will be provided to them. And this haptic feedback in this case is simply vibrotactile actuators, as you can be seen here. So what I believe, because what I believe the future is a combination of haptic wearables and emotion with an instant biofeedback of a very fast network, which is a tactile internet for the well-being of citizens. So we are looking at combining haptic with ECG biometric on a mobile device, so that with the ECG and the haptics, the way we are touching this mobile device, we can capture both our ECG, our heart rate variability plus heart rate signals, and our haptic and as a force with which we capture the phone in order to authenticate users. We are trying to use what we call deep learning to calculate the emotion, so that the emotion can be provided to the avatars that we are building, and the avatar can be touched by someone else. And we did the test in the recent, in the last election in Canada, and you will see here basically after 25 seconds, our previous Prime Minister had a steady heart rate of 58 beats per minute. Now, when our actual Prime Minister, who was his counter candidate that time, started attacking him, Mr. Harper started getting nervous, and this was basically one of the worst debates that Mr. Harper had. He started using his hands, so from psychology we know that he was a bit nervous, and through visual extraction of the heart rate and the emotion, we know that he was at 65 beats per minute. So, in order to prove that this theory is working, we did an uncontrolled experiment during the game of Argentina-Nigeria in the last World Cup, and you can see the biofeedback complete in the smiley face, and I am watching the game. So depending on my emotion, in real time, the biofeedback was given to me, and this I'm presenting it here visually, but it was also haptically to the haptic chair. So we are continuing to develop haptic for well-being, basically. And where you see me falling is for people with Parkinson's disease, and we need basically to develop for them haptic-based underwear, so that when they fall down, it's automatically detected. And also for gloves or haptic-based glove for diabetics, because many of the diabetics, they lose the sense of touch, of the feeling in their fingers. So consequently, when they are grasping a cup or glass or whatever, depending on the force applied, different type of media is presented, such as sound or movement of chair, whatever, and then they will know which force they are applying and whether they should continue applying this force. And for the sake of finishing, is combining the whole multimedia world. I still have 1 minute, I think. So combining the whole multimedia world, we are using eye gaze with sensors, with actuators in order to support, in this case, ALS patient navigate through eye gaze and also in a smart environment, his home. So what are the applications when you combine haptic with audiovisual environment and when you converge those different technologies? Application can vary. So today you don't own your data. With the digital twin you will be able to own your data. Immortality, so your grandchildren, and this is what I believe will be the killer application for haptics. Similarly to today's images and photos and videos, when you look at your grandparents, if you can visualize or virtualize your grandparent and then feel their hug, then it's probably where we are achieving big milestones in haptic. Dating, so I send my digital twin to date someone and then figure out if it works well. Health and well-being, as I said, it's big. So I do believe that the digital twin fits very well in the artificial intelligence strategies in many countries. And it is a digital democracy of the data in the real sense of democracy, but we need to balance the convenience versus privacy. So, and one question that is very much neglected is the ethical. So, ethical characteristic. We are developing haptic applications which include touching, and in Korea, touching is not ethical, or you cannot touch someone you don't is not intimate with you. So, what will happen with the ethical characteristics? So, I would like to thank all the teams that have been working with me, and we'll be happy to answer any question now or later on during the panel session. Thank you.